All right, let's be honest for a second. How many of us actually enjoy needles? Or the thought of having to lug a cooler full of vaccines across a desert? Probably not many.
Not exactly ideal, is it?
Not at all. But what if we could change that? What if vaccines could be shelf-stable, painless, and maybe even, dare I say it, kind of cool?
Well, that's precisely what we're diving into today.
Exactly. In this deep dive, we're talking about the future of vaccines with, get ready for it, metal organic frameworks and covalent organic frameworks. We'll call them MOFs and COFs for short.
Catchy, right.
And to guide us through this nanotech revolution, we're taking a close look at a 2024 review from Chemical Reviews.
A real treasure trove of insights, that one.
The title is a bit of a mouthful. The Promise and Potential of Metal Organic Frameworks and Covalent Organic Frameworks in a Vaccine Nanotechnology. But trust me, it's worth digging into.
Absolutely.
But before we get ahead of ourselves with all the exciting possibilities of MOFs and COFs, let's take a minute to appreciate the challenges we face with traditional vaccines.
Right, because it's not just about sticking a needle in someone's arm and calling it a day.
Definitely not. We're talking about incredibly complex biological systems at play here. So what are we working with? We've got our proteins, our RNA, these delicate biomolecules that need to be kept just so, hence the whole cold chain conundrum.
Which, as you can imagine, is a logistical nightmare, especially in parts of the world without reliable refrigeration.
Huge barrier. But it's more than just storage, right? These vaccines have to actually work once they're inside the body.
And that's where it gets really interesting, because the body's immune response is incredibly complex. It's not enough to just introduce an antigen. You need to deliver it in a way that truly activates the immune system and creates a lasting defense.
So it's like training for a marathon, not a sprint. You need that sustained effort, that constant exposure to build up real immunity.
Precisely. And that's something traditional vaccines often struggle with. They provide a burst of antigen, but it's often gone too quickly to generate a robust and long-lasting immune response.
So we need something smarter, something more sophisticated, something that can work with the body's natural defenses to create that long-lasting immunity. And that, I believe, is where our friends MOFs and CFs come into play.
You've got that right.
So MOFs and CFs. It does sound a little intimidating at first, I'll admit.
A mouthful maybe, but elegant in their own way.
I like that, elegant. But how about we demystify it a bit?
Yes.
What are we really talking about here when we say MOFs and COFs?
In the simplest terms, imagine tiny, highly customizable cages.
Cages. Like at a molecular level. We're talking seriously small here.
Precisely. And these cages are what we call porous. Think of it like a sponge, but with a very specific purpose.
Okay, I'm intrigued. Now we're talking sponges. So how do these cages, these sponges, actually work with vaccines?
It's all about design. With MOFs, we're using metal ions and organic linkers to build these frameworks.
Metal ions, like what you'd find on the periodic table.
Exactly. And these metal ions are connected by organic linkers to form the structure of the cage. COFs, on the other hand, are made entirely from organic components.
So it's like we're using different building blocks to create these intricate structures, each with its own unique properties.
Precisely. And the beauty of this design is the control it allows. We can tweak the size and shape of these cages and even engineer their surface properties.
So it's like we're creating tailor-made delivery systems for vaccines. Okay, so we've got our tiny cages, our custom delivery systems. But how does this actually translate into benefits inside the body? What's the advantage?
Let's start with stability. One of the biggest hurdles with traditional vaccines is their fragility. MOFs, however, are incredibly robust. Some can withstand temperatures up to 70 degrees Celsius. It's like having tiny armored trucks for your vaccines.
70 degrees Celsius, that's what, over 150 degrees Fahrenheit? That's incredible.
It is. And that kind of stability means we can potentially say goodbye to the cold chain, which is a game changer, especially in remote or resource-limited settings. But it's not just about storage. The way these frameworks break down within the body is key as well.
Okay, so it's not a one-time release, it's more controlled.
You got it. We call this kinetic lability. MOFs, and to some extent COFs, are designed to degrade slowly in the body, releasing their contents gradually over time.
So instead of a sudden burst of antigen, you're getting a more sustained release.
Exactly. And the sustained release is what allows for a more robust and long-lasting immune response.
It's like the difference between cramming for an exam the night before and spacing out your study sessions over a few weeks. Consistent exposure leads to better retention.
Exactly. And this is where that customizability we talked about really shines. Not only can we control the release rate, but we can also engineer these MOFs and COFs to be even more targeted in their delivery.
Targeted? Like how?
Imagine attaching molecules that act like homing beacons, guiding the vaccine to specific cells or tissues.
So we're not just talking about delivering a vaccine. We're talking about delivering it with pinpoint accuracy to the exact cells that need it.
You've got it. And it doesn't stop there. We can also incorporate what are called adjuvants directly into the MOF or COF structure.
Adjuvants. Refresh my memory.
Sure. Adjuvants are like the hype men of the vaccine world.
Yeah.
They amplify the immune response, making the vaccine even more effective.
Okay, got it. So these adjuvants, they're usually given as separate injections, right?
Traditionally, yes. But with MOFs and COFs, we can combine everything into a single, elegant package.
This all sounds amazing in theory, but does it actually work? I mean, we're talking about next-level stuff here.
Yeah.
What are we seeing in real-world applications of MOFs and COFs in vaccines?
Well, that's the million-dollar question, isn't it? And the research is, well, it's incredibly promising.
Give me the highlights.
Okay, so scientists have successfully encapsulated entire viruses and bacteria within MOFs and, get this, kept them stable at room temperature.
No way. So no more of this whole ultra-cold storage thing.
Exactly. And it gets even better. One study actually showed these MOF-protected vaccines being shipped by regular mail, and they still worked.
Okay, now that's a game changer. Imagine the possibilities, especially for remote areas. But what about how they actually perform in the body? Do they actually trigger a better immune response?
That's the big question, and the studies so far, they're really encouraging. We're seeing MO-encapsulated vaccines producing a stronger, longer-lasting immune response compared to traditional vaccines, sometimes even complete protection.
So potentially fewer booster shots.
That's the idea. And more durable immunity overall.
That's huge. Are there any examples of this tech being used for specific diseases yet?
Absolutely. One study that caught my eye looked at a MOF-based vaccine for a particularly nasty strain of E. coli that causes sepsis. And in mice, at least, it completely outperformed the traditional vaccine.
Wow, that's incredible. Okay, so far we've been talking mostly about MOFs. Where do COFs fit into all of this?
You're right. MOS have kind of been hogging the spotlight.
Well, they do sound pretty awesome.
They are. But COFs, they're like the underdogs, quickly gaining ground. They might not be quite as robust as MOFs in every scenario, but their biocompatibility is a major advantage.
So less risk of, any unwanted reactions or side effects.
Exactly. Plus, they're entirely organic, which is a plus for some applications. It's really exciting to see these two technologies developing side by side.
It sounds like we're on the verge of a whole new era of vaccine development.
I think so. MOFs and COFs, they have the potential to make vaccines more accessible, more effective, and honestly, less scary for a lot of people.
No more needles?
Well, maybe not no more needles, but definitely the potential for needle-free options, like microneedle patches or even nasal sprays.
Okay, I'm on board with that. It's incredible to think. We're not just talking about making small tweaks to existing vaccines here. We're talking about completely reimagining how vaccines are designed and delivered.
Exactly. And it goes even further than that. What if we could use this technology not just for prevention, but also to treat existing conditions?
Now we're really going into the future. What do you mean?
Imagine using MOFs and COFs to deliver targeted therapies, like directly to cancer cells, or maybe even using them to modulate the immune system to treat autoimmune disorders.
That's incredible. It sounds like the possibilities are almost endless.
Almost. But we're not quite there yet. There's still a lot of research to be done, safety testing, figuring out how to scale up production, things like that. But the potential, it's definitely there.
Well, I think it's safe to say that this is a field to watch. And I, for one, am incredibly excited to see where it goes. Thank you so much for taking us on this deep dive. It's been enlightening.
My pleasure. It's always a thrill to talk about the future of science, especially when it's this promising.
And there you have it, folks. Another deep dive into the world of cutting-edge science. Be sure to check out the show notes for links to the Chemical Reviews article and other resources. And until next time, keep asking questions, keep exploring, and most importantly, never stop learning.